We're going to talk about have a chat about what VR and AR is and potential use cases and what you can do with it and how to build with it also. So let's start off, dive into what these things are and what you can know, right? So this is a really good image that I use to sort of explain what VR and AR is. I know theory is boring, but I need to start with some context. So how many here knows Looney Tunes, the Space Jam movie that came in 2023 and whatnot? So I'm just using those references from there. So virtual reality is basically you are being transported to a different environment and everything else other than you is virtual. Whereas augmented reality is things, individual objects, characters or TV sets or whatever come to you in real world. So that's just a good example that I give to start explaining these kind of things. Diving right into some examples, right? So in today, in terms of augmented reality, there are two major ways in which people use these technologies. One is phone-based AR, the other is headset. We all know that headsets are a couple of years away because it's a physics problem. It's kind of there is a lot of tech, but it's heavy and hard to use, and for a country like India and a city like Chennai, it's just hard. You can't wear it more than 30 minutes. So what businesses and startups and a lot of other companies have done is try to use the existing technology, that is our phones that we have right in our hands, and add camera tech to it. So that's basically some examples here. On the left, you see a Shopify page, you can just browsing on the internet and trying to see a vase, and they have this view in AR button, and you can place that in your room and sort of see if it's good or bad, if the color is good, does it even fit your room, and those kind of things. The thing on the right is basically a capture app also from Shopify, which we will also cover down the line in a couple of slides. So that's AR in phone. Next, there is also AR in headsets, HoloLens, Magic Leap, and MetaQuest and these kind of things. So as you see, you are the only person real in these videos, and you see a couple of other things around you which are virtual. So that's AR and HMB. And the last one is that a lot of people know is virtual reality. That is, you go into a different world and everything is abstracted from your way when you go inside. This is from the Star Wars game that they have in the MetaQuest store. So you see ILM robot, R2D2, and these kind of people. So that's one example on VR and AR. So to sum up, it's kind of a spectrum. On the left, if you have a reality side, and you right, you have a completely virtual slide. On the left is real world. That's where we are right now. And the center is augmented, where you see a bunch of new things, and also you are there in the same thing. Whereas in virtual reality, it's all computer generated and runs on a GPU, and nothing is real. So that's the spectrum. So right. So in mobile AR, two of the biggest companies that make real impact today is Apple and Google, because they control the mobile operating systems, iOS and Android. Apple has a framework called ARKit, and Google has a framework called ARCore. So these are the two things that any AR application today on the market is based on top of. So yeah, that's kind of the mobile AR ecosystem in short. Coming to HMB, today the companies who are making the most amount of money or most amount of impact, I would say, is in the enterprise space, because these cost $5,000, not $500 or $1,000, which only businesses can sort of bear. So there are these companies like Magic Leap, HoloLens, and a few other companies who basically sort of are the leaders in this space. So that's HMD AR. There is no real consumer headset today in the market, just because there is nothing that's small, sleek, that looks like a glass like this. So yeah, that's the current problem. And the last is hardware. So, hardware in virtual reality. There are a couple. The things that I've mentioned here are the Quest 3 and the big screen beyond. Quest 3 is, I would say, the most affordable complete package that you can get today. You can buy it in India also. You can buy it in Flipkart or Amazon. It's 50K, 50,000 rupees. And it has an ecosystem. It can do both VR and AR, and that's, and it has 2 million users and sold 12 million sort of units at the moment. So that's the current landscape of what VR is. And the thing on the right the thing on the right is interesting because it's the world's lightest VR headset, meaning it's 127 grams, whereas the thing on the left is like somewhere around 500 grams. You would say half kg is not something that you can wear on top, but if you use it for 2 hours or 3 hours to do some actual simulation work or like do some real engineering work, you cannot do those kind of things. So that's why like the startup called Big Screen made this headset called Beyond. But the only problem is that is tethered to a PC, whereas the thing on the left is not tethered. So there are some trade-offs when you want to make like a very sleek, lightweight headset. So like yeah, that's why I wanted to put Big Screen Beyond also on the right side. Give a quick rundown on like what happened since the 90s to 2024 today. This is kind of the slide where you can sum up pretty much all the big visual hardware things happened since the 90s. So like we started with web, like the apps and whatnot, and then like we had like 3D effects in apps, skeuomorphism, and like those kind of things. And then like we had this Google Glass moment in like 2000s, where it was like a small heads-up display on the top right corner where you can just see some notifications and whatnot. And then WebVR is when I started working in the space. I'm not sure, how many of you here knew the cardboard headset that Google sold in 2016? Interesting, a couple of people. Glad you folks are here. So that's where I started in 2016. Like one of the first things that I built was like a digital twin in a cardboard headset back in the day, trying to simulate an electrical machine in VR, trying to control, command, and like debug what kind of problems are there. So like that's my first foray into that. And then like the 2012 acquisition of Meta acquiring Oculus happened, and like the whole industry started to wake up, and like it's like a wake-up call in 2012. Yeah, and then like since Qualcomm, MediaTek, and like these kind of companies started to have like good, powerful GPUs in their phones, we saw mobile AR. That's what I showed a couple of slides back. So and then like MetaQuest came along after Oculus. So that's one standalone device that a lot of people are using it today. Not India, US. And then like companies like Magic Leap try to innovate in the enterprise space and like try to go on. And then like the recent last major announcement from Apple, which is the Apple Vision Pro, which is Apple's entry into the enterprise AR market or the consumer market if you have a lot of money. So that's the kind of the history on where we are today. Cool. So let's talk about like how do we build for these things. This is an intro to VR AR talk, but I'll just cover some things on like some frameworks and tools that you can use to build if you want to build or prototype and like do these kind of things. Cool. So when it comes to native, there are like only two major game engines, Unity and Unreal. They are fast. They are like the best in the quality because all the games are built on top of that, and they are like huge in size and like they are GPU intensive. When I talk about one thing that came to my mind when I said games is whenever there is a new technological revolution happening, games industry is the first industry that will use the technology. That is why games in the US on the VR headset is so popular than any other use case. Today, the startups and the companies who are making money in like 10 to 20 million in the Quest App Store are games, no other category, hands down. There is no competition or no other category below that. So like that's the current state of like games and like relations with this VR AR. And just to give some example on like how much fidelity we are talking about, it can be as real as like photorealism. Like that's how much quality you can do. I think in this video you can see the car crash and you can see the glass breaking off and like see all the physics simulated in it. And you can basically go inside this and like be a bystander and see everything in VR in VR headset. So that's just an example on how much fidelity you can see when you build with native things. Maybe you can just watch for a minute. I'm just waiting for the car crashing scene where you will see all the physics. Or maybe I can fast forward. Yeah, right exactly here. So like all things physics are simulated here, and you can see all like talking about use cases on top of these, right? I think I'm not sure if a company is working in India about this, but I think there are in US where people do. Okay, forget that. In Iron Man, when there was a blast in the Iron Man 2 movie, he goes to a heads-up display and like sees the crime scene, right? So that's the level of like quality you see with VR, and like you can do like crime scene analysis using these kind of tools and systems, and you can use Unity and Unreal to build these kind of applications. So like that's just one example. So moving on, the other side is like web. I mean, of course, when you say native, you need to cover web. So like there are a couple of things that are better with web because they run on mobile. That's one thing. They have a smaller footprint. They don't need NVIDIA GPUs, but they can run on Arduino GPUs on your mobile, and they are fast. They load within 2 to 3 seconds, and yeah. So and it's been proven, tested, battle tested with Shopify, Flipkart, Google, and like all these kind of companies. And like it's at a state where if you have a niche use case, you can just forget native, just use web, use one of these WebGL libraries like 3JS or Model Viewer or like Microsoft's Babylon or like React Fiber, and like ship it, kind of. The quality might not look that great, but for a use case particular to what you are trying to build, you can optimize for that. Meaning it might not look better in all aspects, but if you have like just visualizing a product, that means you can make the product alone high quality, and like that's basically it. And in terms of like what you can do, right? From what I've seen, building for web is basically an optimization game. Building things are very easy on web, but optimizing down to like low-end Android phones or low-end Xiaomi and like Oppo. I mean, I'm not saying those brands are bad, but they have like low RAM, low GPU, and like those kind of things, right? So trying to optimize for these things is basically what the challenge is when you try to build with web. Yeah, so we're talking a lot on frameworks, tools, and like these kind of things. But if you wonder where does the content come from, right? That's like 50% of the work. The other 50% is like logic, making sure the business logic is implemented, making sure the presentation is good, and like all these kind of things, right? So when you talk about content can be built in like 3 ways. One is using traditional tools like Blender, Maya, and like all these like traditional 3D tools, and like sort of a human sits and like makes this in like 6 hours or 10 hours and like gives it. That's been for like 20 years now. That's the current way of doing things. For the past 5 years, that's photogrammetry. I mean, when I learned about this, it was funny. Apparently, photogrammetry was there since the 90s, but no one used it until like a few years ago. But yeah, the one that I'm showing here is like Apple's framework called Object Capture. It's interesting that Apple was able to ship this. This thing called Object Capture is an API in your OS level Mac. It's not even a separate software. You can just use some Python commands to like give a bunch of images, and like it gives you a 3D model in like 40 minutes-ish. So like that's object capture, and like NERF and Gaussian splats. Okay, the paper for the research came in 2021 for the third thing here. So it's very new. It's just 3 years old, very nascent. Very few startups work on that, and like yeah, the company that I work at, Luma, works on those also. So like that's that. Trying to compare why you would want to pick one of these 3 things. So as I mentioned, like manual is the most time-taking to make because the human is in the loop. Of course, when you have humans in the loop, scaling is so hard, and it's costly, and it can be done only in PC. I mean, these softwares run only on PCs with medium-level graphics. Next is photogrammetry, right? So there are a little bit improvement from manual. Like you can use images as input, but at the same time, capturing is still hard. You need to, like, for both photogrammetry and NERF, the way to capture things are, it will take 5 minutes to go around an object in 3 different heights and like capture each and every angle. So that's that. And in photogrammetry, there is no reflection and refraction, meaning if you try to capture this table or this floor, it will not work on photogrammetry because they are basically they don't capture in this technique called photogrammetry. Yeah, it's PC only majorly, but there are a few apps that run these things locally on your iPhones also. So like that's that. Yeah, I mean, if I'm saying all these like disadvantages of manual and photogrammetry, you can guess what's good in Nerf and GS. So it's fast to create. The processing times is also like half of photogrammetry, and then like you can use videos, images. Scaling is the easiest, and like yeah, you have reflection support. Refraction support is there, but not deployed on many of the prod systems because it's a compute problem. It will take more time to infer on basically the data and like sort of have it. And it's both PC and mobile, but most of the mobile solutions are like cloud in the loop. So you take the video on the app, but it goes to the cloud, renders it. I mean, builds the whole AI and like gives it back. So like that's Nerf and Gaussian flat. To give an example of what it could look like, right? So here, I think this was somewhere in Singapore. You can basically see the whole street captured using the Luma app, and like you can basically make it like a video game where you can go and interact and like see and do all these kind of things. So like that's that's how high quality it is or how high fidelity it is. So like yeah, that's one example. Cool. So I've been talking about all these things, but you might be wondering also, this all sounds too much. It will take 1 week to even start on this and complete something within a week or like prototype something. That's where like some of these tools that are like Figma, like I mean, how many of you here know Figma? I mean, I assume most, yeah. So there are some tools which help you build these things without trying to spend like 5 people's engineering time on a week and like trying to prototype something. So one, I mean, this is a random example. There's a company called ShapesXR. They basically have this like a headset app where you can do all these kind of like putting blocks, putting chairs, putting all these kind of different things, trying to add interactivity to it, trying to add animations to it, and like build an end-to-end prototype and get the feel of how it works or not, right? I mean, I think recently someone in my company told that prototypes are way better than design, and like it's very similar to how videos are way better than images, right? So you can just prototype with like 2D frames or 2D, basically primitives, and like make something that's very quick and like just see how it works. Send a link to other people in your team or customers, do customer feedback, and like basically build an end-to-end thing, and then like export to Unity when you want to make an end-to-end experience, and like you can basically do it. I think here they are doing like a training example where yeah, you're just designing it on a laptop, and then you can put a headset and like basically see it end-to-end. So like yeah, that's one tool. Cool. Finally, we are at use cases, the most interesting part, and a lot of things are there. So I'll start with e-commerce. Since I was working at Flipkart, I know all these things end to end because I built it, like in part of the team who built it. So I'm going to talk about like this thing called View in Your Room. So View in Your Room was deployed on things like large appliances, phones, anything that needs to be shown on a room, like the stable sofa or like even the stable and like all these kind of things. The success thing, I mean, the reason to do this is, you would say, I mean, yeah, of course, when companies do these, people say it's a gimmick and it's a marketing extravaganza kind of thing, but that's what every company will do. But when you actually see people like at a scale like Flipkart, when millions of people try and use, you try to understand what exactly do they get out of this, right? I've basically sat across a couple of customer calls where Flipkart makes engineers sit across customers and like they say, is it like, what do they think about this product? Is it even useful? And like, how did they use it and like whatnot, right? Some bad things also I've seen is like people don't understand how to use this. That's an onboarding problem. But on the other side, imagine you're buying like a sofa for like $1 lakh. Now, if it doesn't fit your room, what will you do? Those are the kind of problems that Flipkart was trying to optimize for after we released the first version. So yeah, that's one example. This is purely a marketing thing. When Nothing launched its phone on Flipkart, we had the 3D feature, and also we had this, the lights glyph thing lights up and on, and then when you click on it, you can basically move it around in all angles and see where the ports are, see where the things are. And the interesting part is right here. So people may want to compare it with their existing debit card size or their existing phone. So what we add, like this is something that I worked on, is like this debit card thing where you put a real life card like in actual scale and on the side, or put your existing phone, or like choose a phone that you want to compare it with and like see. I mean, until you go to this is all trying to, it is not trying to replace an in-person experience, but we try to show the scale of, let's say you have a 4.7 inch phone, but you want to buy a 5.5 or 6 inch phone, and how does it even look like? So that's that. To try this, I would say take your phones, just scan this QR code, and like if you want to try, you can try. But this is basically the thing that I just showed before. But I think this QR code leads to the CMF phone one that launched yesterday. So yeah, the team is pretty active on putting these things on like live. My old friends were still working that. But yeah, that's one example. One other thing is also a feature called 3D highlights. Highlights is like it's kind of like you sort of show which part of the phone is what. Like let's say you have a Type-C, Type-A connector. There is this carousel at the bottom, which you can swipe to sort of see what feature it is. People who are interested on these kind of things where it's kind of reimagining how a product page on a normal e-commerce website looks like, and this was also very popular when I was there. So yeah, that's one more example. And I think one other feature that we had was like showing the phone break into pieces and show the chip inside it, just for like the namesake marketing thing. But yeah, that's not shown here. Other thing was we worked with, I think it was Maybelline, I forgot the exact company name, but yeah, we worked with them to sort of add this beauty virtual try-on where you can apply lipstick and like sort of mascara and like a couple of other facial products on your face and like see. You can, what I'm showing here is where you can try it on a model. The other two features were also you can try it on your face live, and also you can try it on a photo from your gallery or whatever. So like I think this video is also going to show sort of on your face or from your phone. So yeah, that's one beauty virtual try-on. One other example is, I'll cover this towards the end also. What you are seeing is something called Camera Kit. Camera Kit is a framework from Snapchat. We worked, when I was at Flipkart, we worked with Snapchat to integrate their AR effects ecosystem inside the app. Here you can see this shoe try-on example where you can sort of basically put a shoe on your leg and like see how it looks good or bad. It's not the best in terms of tracking because I think this is 2 years old. I'm just showing some old video, but yeah, I think it should have been improved today. You can see like there are some issues with the segmentation of the upper part of the leg not being properly tracked there. So like that's that. All this is good, but I would like to sort of also show some numbers on, do these actually work? Do people even benefit from these kind of things, right? So happy to say, yeah. As of 2023, June 25, I think Ajay was my engineering manager when I was at Flipkart. We had 1 billion activations across the things that I spoke about from Flipkart within 20 months. Within 20 months of acquiring the startup that I was working at to when we had this big billion day sale. I mean, that's the yearly days that Flipkart sells a lot. So that's one example on like how things are. And some more numbers. So trying to split on each of these features that we talked about, right? The Snapchat thing that I talked was used by like 500,000 people. And then like the beauty try-on, right? I think it's not exactly mentioned here, but I think 25% uplift was given because of they tried the AR and they bought it. So like it was 25% uplift. And then like the particular like furniture and like viewing it in 3D AR was like activated 50 million times. So yeah, that's basically 2022's number. That's also 2 years old. Lot more by now. This is also a metric from Snapchat, I believe, where they say 75% of the people who tried AR say they have higher intent to buy this product if they see it and buy. I think I showed the shoe example already, but on the right, we also did like product launch activations for companies like Asus and like some mobile brands, where we basically build marketing effects, I would say. We called it camera effects back in the day, and like have it there, and like you can see there will be a buy now button on the bottom right corner where that basically goes to the product pages and like buy and like do all these kind of things. And it was not a lot of innovation, reason being it was just Snapchat's SDK we are using it. Also you can see the lens slider, right? I mean it's exactly from Snapchat. I mean it's basically like Snapchat built an SDK out of their best parts of their Snapchat, which is AR, and then like gave it as an SDK, and like we used it. And from what I know, we were the first e-commerce company in India to do it, and like there was one other, Mojo, I think that was the other app that was using this before us. So like yeah, that's that. And the tool that I was talking about was called Camera Kit. It's a pretty, if you have one-off experiences that you want to just ship it to your app, you can basically use Camera Kit. So yeah, that's basically it. And like it has almost all kinds of tracking that you might want from an AR app, from face, body, hand, leg, full body, and like or even room segmentation, sky segmentation, like all these basic things. But if you want to build like a complex thing, that's where you cannot use something like Camera Kit because it's a one-off experience. It's based on effects basically, not custom applications. So yeah, that's Camera Kit. Let's talk about Google. Google has AR deeply integrated into a lot of search experiences. On the left, you can search for like random animals. You can see view in your 3D button. On the center, you can search for molecules and like see the molecule in 3D on your, I think the molecule might be just on the native apps. So you might need to download Google app if you don't have and like try it out. And the right one is like anatomy, like you just search for muscular system. It should be live on India also, but yeah, as far as I checked, it's still there. Yeah, I mean, this is how you can discover things there. One other thing that Google also does is, now let's say you are a company of your own and you are selling something that will have 3D in it. So Google has this thing called meta tags where you can say that my website has 3D in it, and it will populate in the search result as you can see this product in 3D. So I think companies like Shopify, Flipkart was also doing it. Let's say you search for Crystal coffee table on the Google search. If the product that you're trying to look at has 3D model tags associated with it, in the search itself, you will see the button view in your 3D. You can click that and go directly to AR and then go back to your experiences. So yeah, that's one thing that Google also has. Talking about some futuristic use cases that are down the line is like Gaussian splats in 3D VR, I mean in AR and 3D. Just to give some context on what Gaussian splats are, so do people know how a PNG file works? A PNG file is basically an array of colors in X and Y position. That's PNG. I mean, dumbing it down, that's what it is, but not exactly that. Imagine that in 3D, meaning for every point in space for a cubic area, every point will have a color. And also every point will have a color, and every point will have a different color when you look from different angles. That means there will be an X, Y, Z, alpha, beta, theta. So like there are like 6 parameters, and that's basically Gaussian splats in the simpler terms. What that lets you do is this photorealistic 3D capture. So what you think is like, I think one of the community members of Luma, like they capture their mom and dad on a street somewhere, and like you can basically go inside that on a app. This is captured on Apple Vision Pro. You basically are in a 6 degrees of freedom environment. You can go in and check it out. So it's, imagine photos, but for the future, kind of, and viewable on headsets. So like that's a Gaussian plots example. And just to show some more examples, this is a capture that I made in New York, I guess, where the entire room is captured and you can go inside and sit there and like you can see the portrait in the wall and like you can see all the statues and those kind of things. And even see the details on the table on like what numbers are there, what is the texture and like all these kind of things. So like since I told it's like the 3D XYZ and alpha beta theta, you have, I mean it's interactable. I'm just using my mouse to move it around and show. So yeah. And the same thing, I mean, I didn't have time to put it on a VR headset and show, but the same thing can be viewed on a Unreal Engine exported VR app. You can put this and like go inside and see it. So like that's one example. Just to show some more interesting use cases that other companies have made, the Sweden-based company, IKEA has been doing this since 2017 also, which was interesting to me, so I wanted to add this. So here, they kind of have things similar to Flipkart, but at one point of time, I think they had the most number of 3D products in their website, which is like the highest number in like 2018, I think. So yeah, there's just an ad, but yeah, they basically show how you can browse, how you can take a product, how you can customize it, and then how you can place it and check. So like that's one example. The other example is also sort of, this is also live today. If you are buying a new house or you're going to a new place and you want to set up a few items in your room, IKEA lets you use their app and put IKEA products, of course only IKEA products inside the room, and basically check out. That's pretty much it. Like you place things on your room on the exact size and measurements you want and place the order. So that's how simple it is. So like that's one example they have. It doesn't just do that. I think they also have like, you can choose the wall texture painting, what you want, and like choose it and like those kind of things. Speaking of that, I think you folks know Shopify, right? The other giant in the world who does e-commerce, self-serve e-commerce and whatnot. They also, I didn't include them here, but one of the companies that they acquired was like a hyper-realistic wall painting app. It was basically like you show the app around your room and basically put like the texture and the shade and the opacity that you want directly on your wall, which is exactly like what it will look like when you do an actual wall painting. And like, yeah, that's one interesting use case that they did.
For question and answer and any interaction if you have.
Actually, for the things you told and other examples that were given about mapping lenses, mapping spectacles, so there is this module called MediaPipe in Python, for which you can use landmarks to track parts in your features in your body, face, hands.
Yeah.
So, and all those are actually a collection of trained machine learning models in a way.
Yeah.
So, is it actually safe to say the fact that actually machine learning is required in one way or the other to track real life features with the virtual world? For example, if you have to place a sofa somewhere, you actually need to track specifically where the other items are kept in that room. Only then you'll actually get an idea of the size, dimension.
Yeah, all these systems, ARCore or ARKit that I mentioned, Google and Apple, yeah, they use this thing called SLAM, simultaneous localization and mapping. So those run continuously in the background to detect the floor if you are using a phone, or that is one way, which is a camera-based solution. The other way is using tracking sensors or markers, like you said, or even like, yeah, I think those are the two. But yeah, of course, these things cannot be, like VR AR cannot run without these things, if that's your exact question. Yeah.
The dream machine you are talking about, how does it have like control over the character? Because there are a lot of opening in your Sora models which doesn't have exact like character control.
Yes.
As in, you can't animate the character. That's a universal problem with the timeline editor as well.
Yeah.
So how does Numa think of addressing it?
You should try a video that is image conditioned video model, meaning you can give the first frame of the video. The thing that you're seeing is the first frame was the poster, and it basically made a video out of it. It's a very simple example. But yeah, this was conditioned on an image which has the character consistency. And because of the training data that we use and like a lot of understanding of real life videos, it can stick to, like my faces does not change as the video progresses, or even the text does not move around and like do these kind of problems, right? So yeah, that's one conditional thing. And on top of this, the product that we are working on will kind of cover these steerable things where you can steer it with language, you can steer it with UI, you can steer it with like a virtual camera saying go front, back, left, right, and do something. So like, yeah, these kind of things are in pipeline. Okay, that's pretty much it from my side.